Hello everyone. In this video we will talk about graphs of function and also the effect of a change in a function and how it will shift the graph. So let's just start. When presenting a function in a graph, we use the Cartesian coordinate system, or sometimes it is also called as the xy plane. It is obtained by drawing two perpendicular lines, which is called the coordinate axis. We have the x-axis as the horizontal line and the y-axis as the vertical line. This x and y-axis consists of all real numbers and point O on the origin point. The coordinate axis separate the plane into four quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Any point in the plane can be represented by a unique pair xy of real numbers, such as the points shown here, point P and point R, where P is a coordinate of 3 and -2 and R is coordinate of -2 and 3. You can see here that the coordinates in the plane are ordered pair because the order of the two numbers in the pair is important, as shown by point P and R, where 3.-2 is not the same with -2.3. Now let us continue discussing about the graph of a function. As we all know, each function of one variable can be represented by a graph in this rectangular coordinate system. Such representation helps us visualize the function. Let us try to graph the function as follows. Fx equals to x squared minus 4x plus 3. We begin by choosing some numbers. Here we choose the number 0, 1, 2, 3, and 4 and plot to f of x. So we plot these numbers to the function and get this result. Then we plot the point shown in the table in the xy plane and draw a smooth curve through the point. So we have 0.3 here, 1.0 here, 2 minus 1 here, and so on until 4 and 3. And then we try to connect the dots into a curve. When we try to plot the graph of a function, we must try to include a sufficient number of points. Otherwise, we might miss some of the important features of a function. For more complicated function, we have to use differential calculus, where we will discuss later on, to decide how many bumps and wiggles exist. In this section, we will see how a change in a parameter causes a shift on a graph of a function. If we have f of x, how would the function relate to the graph of the associated function? If f of x is added by a constant, c, if the variable x is added by a constant, c, if the function of x is multiplied by a constant, c, and if the variable is multiplied by -1. So let's see the first effect if the function f of x is added with a constant c. We use the example here, y is equal to the square root of x, or here I rewrite to the power of 0.5. And we would like to see the graph of f of x changes when fx is added with a constant 2. We see here that the graph moved upward when added with +2 and moved downward when added with -2. As said by Rule 1, if fx is replaced by fx plus c, the graph is moved upward by c units if c is greater than 0, and it is moved downward if c is smaller than 0. Now let's see the second effect, where f of x is replaced with fx plus c, or the variable x is added with a constant c. Here we see that x minus 2 for the first effect and x plus 2 for the second effect. You see here between the blue line and the red line compared with the purple line. So the effect is the graph is moved c units to the left if c is greater than 0, as shown in the blue line compared with the purple line, and it is moved to the right if c is smaller than 0, as shown as the red line compared to the purple line. Now, what if f of x is multiplied by a constant? So here it is the f of x is multiplied by 2 for the green line and multiplied by -2 for the purple line. And the effect is the graph is stretched vertically for c greater than 0, as shown by the green line. You compare it with the original red line, and is stretched vertically and reflected about the x-axis if c is smaller than 0, as shown by the purple line compared with the red line. So let us see the last effect. That is, if the variable x is replaced by -x. Here we have x, square root of x becomes square root of -x. So we have the light purple as the original curve and the dark purple as the effect. So the effect is if variable x is multiplied by -1, the graph is reflected about the y-axis. We have seen the 4 changes on the function fx. We can use the rules as a rule of thumb on what happened to a graph when added a certain constant, whether we add or multiply a constant to the variable or to the function. Now I want to add some additional note. In our previous example, we saw that the function was fx, where x is where the domain is located, the x-axis I mean, and the y-axis contained the range. Now what if we want to see the effect of change if the function is reversed, where y becomes the independent variable, so x is a function of y. So with the same change from our previous example, all we need to do is, in the first 2 rule shown by the first 2 examples, interchange the word upward to the right, upward with to the right, and downward with to the left. In the third rule, we change the word vertically to become horizontally, and in the last rule, y-axis to become x-axis.